Okay. So is this separable? It is, right? And you know how to solve it. It just becomes x, or EU du is dx divided by x. Oh, didn't share my screen. Share screen. Okay. Okay, so integrate that. You can easily solve this differential equation. Once you have the answer for you just back substitute to get y. Okay. So if you integrate that, what do you get? So on the left-hand side, you get this integral is just e to the u. And the right-hand side is ln x. There's also some c constant, right? Okay, and now all we have to do is we say u was equal to y over x. So e to the y over x is ln x plus c. And actually, you can just leave it like this. That's okay. It's an implicit solution. You can make it more simple if you want, but this is okay. Yes. This x, you mean? Or this one? Yeah, so x equals to 0, that's not what we're interested. That's just saying the solution is at just one point. But x is a variable, right? You want to find this for all x. Okay, so this is really my differential equation. Whenever you have like y times something is 0, x times something 0, that's not the solution you want. You want the other bigger term to be 0. Okay, any questions? Yes. Is there an initial condition? Oh, okay. Yes, we have an initial condition. So that means you have to find C. If an initial condition is given, you have to find it. So what is the initial condition? Y at 0 is 1. Okay, let's plug in x is 0 and y is 1. Or was it y at? Wait. Did we do this right? Y at 0 is 1. I think this initial condition was wrong, probably. It's a typo. I have to go back and check it. So for now, let's forget about that. I'll double check. Because x0 doesn't make sense here. Yeah, I'm gonna double check. Let's say we just have the general solution, not the specific one. Okay. Any other questions? Okay. So we're a little short on time. I'm going to go a little fast. We're going to come back again if there's time to this Bernoulli's equation. Let's move on to the next one. The second problem is critical points. You have this differential equation. The slope is equal to 10 plus 3y minus y squared. First, find the critical points, then classify them. Are they stable, unstable, or semi-stable? Okay. So how do we do that? How do you find critical points? slope has to be 0, right? Which means dy dx is 0. So set the slope equal to 0, find the points. You're going to have 2 points. So what are those 2 points? Try to find them. You can multiply by negative to turn it into the quadratic form you're maybe more familiar with. Y squared minus 3y minus 10 is 0. Actually, you can just also write that as y minus 5 times y plus 2. Okay, but let's use the quadratic formula. It's 3 plus minus square root of 9 minus 4 times negative 10, so plus 40 divided by 2. Okay. So square root of 49 is 7. So 3 plus 7, one answer is 10 divided by 2, 5. The other one is 3 minus 7 divided by 2, negative 2. Right? Questions? Okay, so now you can draw this phase diagram line, which basically shows y and these critical points. The critical points are, if this is 0, this is 1, 2, 3, 4, 5, go up. 1, 2, 3, 4, 5, and negative 1, negative 2. Right? And you want to know the sign of the slope above 5, between 5 and 0, and below 0. So what is the sign of dy dx, the slope, if I plug in something that's greater than 5? You can try something very large, like something that's very easy. You just want the sign, right? You don't want to do the calculations. So for example, you can put 10 or 100. So plug in y equals to 10. Is that a positive number or negative? Negative, right? So here, dy dx is negative. Again, you can just try anything that's greater than 5. 1,000.
A lot higher than that.
Usually it's easier, right? But you can put 6, any number. What about between 5 and negative 2? So for example, you can put 0. Is it positive or negative? Positive. So greater than 0. And sorry, 2, not. From here to here. And lastly, something that's less than negative 2. So let's put like negative 10. You get 10 minus 30 plus 100, which is positive, right? Does everyone agree with this? Any question? Yeah.
For anything less than -2,
Is it negative?
would it be negative?
Oh, right, because it's not negative. Yes, it's minus 100. Yes, it's negative. Good point. Okay, so if I look at the flow of this equation above 5, it's going down. If I look between 5 and -2, it's positive, so it's going up. And something that's smaller than -2, it's negative, so it's going down. So which point is stable? Which one is unstable? Everything is going to 5, right? If I look around 5, if I go here, I go back to 5. If I go here, I go back to 5. So 5 is stable. And -2 is unstable. Because it's moving away from -2 in both directions. Okay. It's going to be semi-stable if for example, this one is going down and this one's going down. So from one direction, it's going back, from the other direction, it's going away. Any questions? Okay, so that's the other thing you need to know for this midterm, is finding these critical points and their stability. And lastly, we have chapter 4. Any questions from 1 and 2? Okay. So chapter 4, by the way, I can go here to the formula sheet again to talk about this. So chapter 4 is about higher order differential equations, like second order differential equations. The first thing we learned was reduction of order. So this one says, if I know one solution for this second order differential equation, if I know y1, can just use this formula to find y2. Okay? You can do the whole process, or you can just use the formula, which is much easier. All right, so we're going to use this formula to solve problem 3. You have the second order differential equation, y double prime minus 2 over x y prime plus 2 over x squared y is 0. You know one solution is just x, and you want to find the second solution. Yes.
So in this case, would P of X be the 2 over X?
Yeah, negative 2 over x. Okay, so again, what do? You just compare with the standard form. A very common mistake in the first midterm was forgetting to put everything in the standard form before following the steps. So please make sure to put it in the standard form. This is already in the standard form, so that's good. And now we use the formula, right? So P of X in this problem is -2 divided by X. So Y2, what is the formula? Can someone tell it to me? It's X, Y1, right? Times the integral of e to the negative P x dx divided by y1 squared. Let me just put this as y1 for now, dx. So you have two integrations, right? And you're integrating the whole, this whole fraction, not just this numerator, okay? It's everything together. Okay, so let's start just plugging in y1 and p. And again, why don't you try to do this first, like 4 or 5 minutes, and then we'll do it together. I find it easier to first do this integral. So usually I write this separately on the slide. Then once I find it, I plug it in here because it can get a little messy. Done. Questions? Does anyone know how to do this integral? Easier to just move the constants out. So that would be e to the 2 ln x, right? And is this equal to 2x? No, right? That's a, again, very common mistake. I'm teaching fluids this semester, and in fluids, we sometimes have to integrate, and students sometimes will forget this, okay? So that is, how do I do that? I need to take the 2 inside the ln. And then I can apply the exponential. So this becomes x squared. Right? Any questions? Right? So that's just this part, this term in the formula. I need to now plug in everything I have. Y1 was x. The integral is numerator, you have x squared. Denominator is also x squared. So that's very easy, actually. Right? So you just have to multiply x by integral of dx, which is x. So you just get x squared. So your two solutions are x and x squared. Any questions? You don't need the constant here, constant integration. because these are just those two fundamental solutions. When we write general solution, that's where you have C1x plus C2x squared. Here you don't need to do that. And if you remember last time when we talked about the repeated roots, I said one of the solutions is e to the x, the other one is x times that. It's the same process. You can use the formula to get something similar to that. Okay, so finally, speaking of the repeated roots and those three cases, we have this question with two differential equations, our second order linear constant coefficients, homogeneous. So that's what we talked about last week. You can think of this as the mass spring damper system. So I will let you work on this one. These are, again, really, really important. You can be sure you will have at least one problem like this on the exam. And you have many in your homework because I really want you to master this, these kind of equations. I think in your homework you have like 5 or 6 problems. Okay, so in order to solve them, before you solve it, let me go back to the formula sheet and just review. Okay, so we have constant coefficient linear ODEs. The form looks like this. You know the solution looks like e to the x, e to the mx. So if you plug that in, you get just the auxiliary equation, right? Or you can just straight go to the auxiliary equation. That's fine. You can just say it's am squared bm plus c, right? So you get the second order. The second order gives you the m squared. The first order gives you m. So you find the roots of this, and based on the nature of the roots, you're going to have 3 different cases. And always in your exam, first identify which case you have. So if you have 2 real roots that are not the same, that's case 1, distinct real roots. And the solution of that case is something like this: C1 e to the m1x plus C2 e to the m2x. If you have repeated roots that are real, like both of them, let's say 2, m1 is equal to m2, then your solution looks like this: C1 plus C2x times e to the mx. Okay. Lastly, you can have complex roots, which looks like this: alpha plus and minus I beta. And the solution will be e to the real part, alpha x, times C1 cosine beta. Beta is the imaginary part, plus C2 sine beta x. Okay. This is what we talked about last time, right? We use the Euler's equation, Euler's formula to get this. Any questions? Okay. So now you have 2 examples here. First, find the roots of the auxiliary equation, identify which case it is case 1, 2, 3, and then write the solution. This is the most important part of this chapter, and it's actually the easiest one. You just solve the quadratic equation, and that's it. If you're done with both of these, you can go back to the Bernoulli one, try to solve that one. which is here if anyone wants to write it down. So first question is which case? Case 3, complex conjugate roots. So the roots are -1 plus minus, that's 16, right? -16. So the square root is 4i. So divide by 2, you get 2i. Right? So y as a function of x is e to the negative x, the real part, times some constant, you can call it C1 or A, cosine of what? 2x plus C2 sine of 2x. Any questions? So if you're done with this one, you can try the second one. Before we do that, what does the solution look like? I might ask you to just qualitatively show me the curve. So what does the curve look like? It's decaying. And is there any oscillations? There is, right? This part tells you there's oscillations. This part tells you it's decaying. So it will look something like this, maybe. Depending on initial conditions not given, it might be given to you. So it will do something like this. Okay. And if I give you a physical problem like a mass spring damper system or a pendulum, I will always give you the equation. You don't need to worry about doing a force balance or anything like that. I will give you this. but you know what it means, right? So displacement over time is oscillating and decaying. And in the context of that problem, what kind of damping is this? Over damped, under damped? Which one is it? It says under damped, right? It's under damped. So again, you might see this problem, but in a different, like a physical application kind of context. Any questions? Okay, let's do the other one. Or actually, I think Bernoulli is a little bit more difficult. So just this one, which case it is? You can just tell me that. The first one, or second one? Did you first do the calculation of the roots? I don't think it's super. Plus minus 100 minus 40. It's more than 48. The numbers are not very nice. Like you have to, when you do the square root of 60, I don't know what that is, 7 point something. Yeah, you can have calculator. But not the calculators that can graph stuff. No plotting. So B, I'll let you do that one. It will be over damped, case 1. Because the roots are like m squared plus 10m plus 10. So the two roots will be negative 10 plus minus 100 minus 40. And that is, again, I don't know what the two answers will be. You can use your calculator. And the answer will be e to the m1x with some constant plus e to the m2x. And when you plot it, you just get it decaying. So you just get something like this. It decays with no, oh, I don't know if it decays or not, because you can have a positive, right? So depending on the sign, all we can say right now is there's no oscillations. It might actually grow depending on the sign. So it will either look like that or maybe like this. Okay. So actually both roots are negative, right? Because this is 7 point something, it's less than 8. So yeah, both are going to be negative. So because of that, it's just going to decay. Okay. Does that make sense? Is that clear? Again, you have many examples like this in your homework. So if you have any questions, let me know. Okay. So let's do this Bernoulli equation. I think maybe Bernoulli is a little bit trickier than everything else. That's why I posted that video. So I'll give you some time. If you watch the video, just follow the steps. If you haven't, just go back in your notes, see how we solve Bernoulli's equation. First, you put it in the standard form, right? Then we have the formula sheet here. So the standard form looks like that one. The difference is, sorry, it looks like, I mean, this one here. The difference is, it's just y prime plus px, right? The difference is on the right-hand side, you have y with some n exponent. And that is very important. You have to find n first. And n is not 0 or 1, okay? So something that's higher than 1. You do the substitution of u or v equals to y to the power of 1 minus n, okay? Then you, again, plug it in, write the equation in terms of v and x. So you don't want to have y anymore. Once you do that, you should get a linear equation that you can solve with integrating factor. So that's what we did in midterm 1. And because of this, by the way, I forgot to say, I'm gonna also give you the formula sheet for midterm 1. So you're gonna have both formula sheets, both midterm 1 and 2, okay? And then once you have the solution of V, you back substitute to get Y, okay? So with that now, try to solve part A of problem 1, and that will be our last problem.
Sure thing. The quadratic formula is F.
Wait 2 more minutes. So okay. So that might not be enough time to solve this, but that's okay. Let's just go first through the first part. First, writing it in the standard form, that's always the first step. If you remember the standard form, there should be no coefficient here, should be 1. Then you have p of x here, that's 2. And then you have on the right hand side, you could have a constant number here or a function of x. And then on the right hand side, we have some function times y to the power of n. Okay, so n is 2. And this tells us this is a Bernoulli equation. Then the substitution we do is v or u equals to y to the power of 1 minus n. And here that's 1 minus 2 or negative 1. Right? Okay. And now you want to rewrite that equation in terms of the new variable v, right? You don't want to have y anymore. So what do I need? I need dy dx or y prime, right? So we know v is y to the negative 1, inverse of y, which means y is inverse of v, right? And now I can find y prime. What is y prime? Negative v to negative 2 and a v prime. This is something that I also forget. Okay, so don't forget the v prime. If you forget, once you go back to plug it in, you'll see you don't have a differential equation. So you can come back and fix that. But you need some derivative, otherwise it's not a differential equation. Okay, so let's go and plug it in. What do I get? I have y dy dx. Y is v to the negative 1. Dy dx is negative v, negative 2, v prime. Plus, so here we're just, oops. Here we're just plugging in. Plus 2 times y squared, v negative 2 to the power of negative 2 equals 3y cubed. So v negative 3 e negative x. Is that correct? Hopefully that's correct. Yeah. Okay. So let's see if we can simplify this a little bit more. What do we want to get? We know our equation should turn into what kind of equation?
Linear.
A linear one. Okay. So I have here negative v to the negative 3 v prime plus 2v negative 2 equals 3v negative 3 e to the minus x. So what we can do here is we can multiply this by v cubed, right? This common factor, the v cubed, or the v to the -3, which you can pull out, or just multiply everything by the v cubed. Does that make sense? So what do we get on the left-hand side if I do that? Anyone? What did I get in the first term? Negative v prime. What about the second term? 2v equals 3e to the -x. Right? Okay. Now, this is a linear equation. Again, maybe to turn it into standard form, it's better if we multiply by negative. So if I do that, this becomes positive, this becomes negative, and I get a negative here. Because if you remember, the standard form of a linear equation was y prime plus p times 1. Okay. So how do I solve into linear equations, first order linear equations? You use integrating factor. Do you remember how to do that? Mu of x is p of x dx, exactly. And what is p here? -2. Okay, so that's just e to the -2x. Right? So what was the next step after the integrating factor? We multiply it, right? Let me write down that this is linear. So once you multiply, we will have, if we've done it right, you should get something like this. d dx of e to the -2x times v is -3 times e to the -3x. You can verify that. You don't need to, we don't have much time, so I'm not going to verify it, but you can verify that this is true. Right? You take this mu, multiply by this term, and this term, and the left-hand side should be with, you should be able to write that as just a derivative of unknown function times the integrating factor. Okay, and the right-hand side is e to the -2x times this. Okay, all right. So if we've done this correctly, now we have a kind of separable equation, right? I can take the dx to the right-hand side and then integrate. Okay, so the integral of the left-hand side will be e to the -2x v. What about the right-hand side? Is it 9 or, so you're doing the derivative, so you divide by -3, which just is 1, right? So e to the -3x and plus some constant c. Always check, like when you integrate, go back, see when you take the derivative, do you get that? So now if I take derivative of e to the -3x, I get that, right? Okay, so we're trying to find v in terms of x. So I can multiply or divide basically by this, e to the -2x. What do I get? I get e to the -x plus c e to the +2x. Okay, we are we have found a solution for V, but V is not what we want to find. We want to find Y, right? So now I go back and see what is the relation between Y and V. Well, it's here. So V was just, V is Y to the -1. So basically we found Y to the -1 is equal to this. Right? And now you also have an initial condition. Hopefully this one is right. If it is correct, you can just plug it in to find C. Okay, so let's do that. And then we're done. So what's the initial condition? Y at 0 is 1. Okay, so if I plug in x equals to 0, on the right-hand side, I get e to the -0 plus c e times e to the power of 0 has to be equal to 1, right? Because the inverse of 1 is just 1, and this gives me 1 plus c is 1, and c is 0. Right? So finally, our answer is y to the -1 is e to the -x, or you can say y is e to the x. Okay. Any questions? I don't know if anyone else got the same answer. Okay, good. Right. Let's see. All right, any questions about the exam? So again, we'll have additional office hours. Our regular office hours are tomorrow in person. If you show like a big improvement, let's say above 50%. So first midterm, if we got 10 out of 30, was it out of 30 or 20? So I don't know, let's say you got 50%, right? And then you now get above 75%, which is a 50% improvement. Then I will reduce the weight of this first midterm for you. Okay. So basically the second midterm will be, instead of 50-50, the first midterm can be 25, the second midterm 75. Okay. So make sure to study for this one. Again, the formula sheet is there, so don't worry too much. Just do a lot of practice. All right, I'll see you next time. And try to be on time. We're going to have the whole 75 minutes. Okay. Thank you.